With our final panel, we really need to highlight decarbonization solutions. You say why? Well, because on a global scale, it's expected that 2 trillion square feet, that's equal to the built environment in New York City, will be constructed every 35 days for the next 35 years. So think about that, adding a new New York City every 35 days. Yeah. That's why decarbonizing the built environment is absolutely imperative. But thankfully, we know some really intelligent people who can discuss tangible solutions and strategies for reaching net zero energy, water, and carbon in homes and buildings. Peter Pfeiffer is an internationally recognized architect, interior designer, and building scientist, professionally licensed in Texas, New York, New Jersey, and Oregon, as well as with the National Council of Architectural Registration Boards. Pfeiffer has spent over 30 years designing and developing pragmatic, high-performance green buildings and homes. In 2004, he was named a Fellow of the American Institute of Architects for his lifelong achievements in mainstreaming green building. And Peter has been listed as one of the 10 most influential residential architects of the decade. And I was very thankful to be a part of the process that awarded him the prestigious Sustainability Superhero of the Year by Green Builder Media. Now, Bronwyn Berry is an award-winning architect based in San Francisco, California. She truly has a global perspective, having been educated in South Africa, the UK, and the US. She organized and directed California's first all-women construction crew for Habitat for Humanity before founding both Passive House California and the Passive House Network, where she currently serves as policy lead. She has been an active contributor to the UNICEF's Coalition on Buildings, working to develop a global standard for high-performance buildings. She's worked with the California's Codes and Standards team on exploring a multifamily Passive House REACH code for California. And she was recently named a Senior Policy Fellow by the New Buildings Institute, and her firm, Passive House BB, was honored with the highest merit award for the 2021-2022 Architecture at Zero Design Competition. And finally, Steve Easley is an internationally recognized building scientist and construction consultant, specializing in solving building science-related problems and educating building industry professionals and their trade partners. His work focuses on increasing quality of construction, sustainability, performance, and reducing costly mistakes that then lead to construction defects and callbacks. Steve's mission is helping industry professionals build and remodel structures that are durable, energy efficient, healthy, and comfortable to live and work in. He has more than 30 years of industry experience, performing thousands of job site quality surveys and presenting building science seminars around the world. Sarah, I will let you take it away from here with our panel.
Wonderful. Peter, Bronwyn, and Steve, thank you so much for joining us today. It's wonderful to have you here. For those attendees who have been with us yesterday and today, you know that our 4 keynotes were very, high level, lots of vision, lots of, just talking about large concepts, big ideas. Yesterday's ESG panel was intended to filter those big ideas down to tangible concepts in the builder, developer, manufacturing, and investment sectors. And today's panel, I'm so excited about it because we're really trying to get pretty far into the weeds with respect to talking about real solutions for decarbonization in the built environment. And as Mike said, I have 3 of the industry's leading thinkers, building scientists, architects, passive house experts to talk with us about decarbonization solutions. So I want to just stop talking for now and let you 3 kick off the panel. I'd like to hear from you about essential decarbonization solutions for the built environment with respect to, first, Peter, if you could focus on sustainable design, then Steve, if you could talk about building science, and then Bronwyn, if you could talk about passive house concepts. So Peter, take it away.
Well, thank you for that nice introduction, Mike, and hi, Sarah. Well, let's talk about this because this has been a subject that's been near and dear to my heart since I was a kid. And I mean that. It was President Carter, I think in 1973, that gave that famous speech about putting on a sweater and turning down the thermostat, and then developing the first energy standards in the country called the BEPS, the Building Energy Performance Standards. That was 1972 or 73, and that pretty much solidified what I want to do with my life, and that's what I've been doing since then. My frustration as we talk about decarbonization, though, is that it really doesn't, there's so much conversation about the things that there's not enough conversation about the thought that should go into how to achieve that. I really believe that we, as architects, are putting our head in the sand and not really thinking about the fact that a project, energy consumption and materials consumption and its carbon footprint starts before design. It starts with proper project programming. Let's talk about the consequences of what the client is asking for, and let's give them some information so they can maybe make more informed choices and perhaps shift their focus. As a crude example, people seem to be very much thinking that they have to build a bigger house to get a better return on their investment in the present residential real estate market. Bigger is better. It's a lower price per square foot, or it's a path towards a lower price per square foot. I think it's incumbent upon us as architects and those who are in the development community and construction community to make folks aware of the fact that, look, if you have an interest in decarbonization, and I hope you do, let's start off by questioning whether or not you need all that square footage to be built. Before we even worry about the tankless water heaters or the solar panels on the roof, let's ask ourselves, do we really need to build a 5,000 square foot house? Is it the wisest choice, not only for society, but for us and our as we age? You'll be paying in property taxes and insurance and energy bills entirely based on the size of that house. So that's what I mean by programming. Maybe a 2,500 square foot house for a well-set empty nester couple might be just big enough, and certainly a lot easier to take care of. So those are some examples of the subjects that we bring up in pre-design, known as programming. But as I thought about this decarbonization push, I wanted to bring up the fact that what we saw here in Texas was something that maybe flies in the face of the traditional approach to decarbonization, because we saw during what we call the snowmageddon here, where we had no power for over 5 days, and it was in the teens and below in terms of temperatures and a fair bit of snowfall, that those of us who did have natural gas, at least for our stoves and for our to help us with our fireplaces, we were able to stay in our homes. We were able to survive. Now, that's one approach. The other approach would have been, okay, maybe if we had had generators, we would have been okay too. But what do the generators run on? They're running either natural gas or propane, or perhaps diesel, but more realistically, natural gas and propane. So I just wanted to bring that up to make sure as we think about decarbonization, we also think about resiliency, the ability to remain in your building or in your home throughout a natural disaster. That's my definition of resiliency. Okay, enough on that. I think as we talk about programming and mix in resiliency with decarbonization, I want to bring up some questions like, do we expect that the Earth is, or the climate's going to be getting cooler or warmer throughout the rest of our lifetime and maybe our children's lifetime? I think the answer would be that it's going to be getting warmer, which means we're going to have an increase in what we call cooling degree days. So even when we didn't have to think about air conditioning in Montana 20 years ago when we were doing projects, today we probably do. Same with Chicago. It used to be considered a northern climate. We're always concerned about insulation values and things like that. But I submit to you, we have to think about solar radiation too. We can't be building these high rises, whether they be in San Francisco, Chicago, or Austin, Texas, that have no climate responsiveness in terms of its design. We have a hot afternoon sun. We have to respond to it. I feel more and more strongly about it as I see my fellows in the American Institute of Architects Awards. getting wonderful awards for these wonderful looking homes and buildings that seem to have such a poor climactic design. We've got to grow beyond that. And I think we can grow beyond that. Once we do think about design decisions that that will affect solar radiation, we do have to think about the envelope and energy reduction strategies. For example, number one is infiltration losses. That's the most important aspect of an envelope that we have to deal with. And what goes hand in hand with that is duct losses, because if your air conditioning and heating system ducts leak, then the house draws in, or the building draws in, more unwanted air from the outside. So you got to build a tight envelope. I don't believe in this malarkey, at least in the South, for these breathable homes. And we have to build a tight ducting system or go with a non-ducted system. We've got to think about windows from a perspective broader than just what is the tinting of them and what's the solar gain factor. No, some type of brim over those windows, some type of awning, something to diminish the amount of solar radiation that hits the glass in the first place is paramount. Otherwise, you're just putting a Band-Aid on a bad design. I know I'm speaking frankly here, Sarah, but what do you expect? Going on down the list, the choice of the exterior color is critical. You know, a dark brown or dark gray or black house, which is so popular now, is probably going to be, the wall temperature will be about 30 to 40 degrees warmer than if it's a very light blue or white or off-white color. So our designer choices also have an effect on our ability to decarbonize. And maybe that's a good place for me to stop, unless you want me to go on, Sarah, because I know I just ate up my 7 or 8 minutes.
That's great, Peter. Thank you. And you brought up some really interesting concepts. First and foremost, really understanding how much space do we actually need? What do we really need to have a good quality of life? And maybe bigger is not better. In fact, I think we kind of know that nowadays bigger is not better. Steve, can you talk about decarbonization solutions with respect to building science, since that's your area of expertise? Oh, Steve, you're on mute, I believe.
Thanks. Sorry about that. Yeah, I was happy to Peter's point about, things getting warmer. Last year in the Phoenix area where I live, we had 167 days over 95. We had 145 days over 100 degrees. We had 53 days over 110, and 14 days over 115. And so that certainly has a huge impact on comfort. We have an awful lot of tile roofs out here, for example, that just do nothing more than soak up the heat all day long. And then, of course, our peak here, we have roughly 1,000 rooftop solar systems going in a month in the area. And so when you look at that, shifted our whole peak. And so peak loads here are now from 3 to 8 o'clock at night, you're paying demand charges. And so the way that we buy electricity, the way that we use energy today is way different than what it was before because of, I think, of warming. But there are some good solutions for that. And some of the biggest issues I see with decarbonization and electrification happening in a timely manner is, number one, I'm not sure the utilities are even ready for this. In my project here, I'm doing a kind of a down to the studs remodel and of a 1970s house. And we have underground service in our neighborhood. We had 4 houses on this transformer. And so when they went through it and did my load calculations, they said I have with electric vehicles, I'm going to have I need to have a 400 amp service instead of a 200 or 225 amp service. So I have to upgrade my panel. And they said, well, oh, by the way, one of the things that we're not sure about, we're not sure whether your transformer can handle the load with the other houses on the street. And so you may have to purchase a new transformer to the tune of $12,000 to $16,000. So I don't think nationally we're paying close attention to this. And I think I would really urge the policymakers at the state level, at these public utility commission levels, to really start talking to utilities and asking them, are they prepared for this? My conversations with about 5 utilities is that I don't think anybody really wants to talk about electrification, the impact that has on the grid, and whether or not, like in my neighborhood, what happens when my other 3 neighbors decide they want to electrify, or for that matter, even purchase electric vehicles? So I think we have to get real about the capacity of the grid on the local level. So where that comes to fruition with regards to, I think, building science messages is that if electrification and decarbonization is going to happen, it's going to happen on the customer side of the meter. And so that means we have to start building buildings that are way more energy efficient, and we have to get away from that cost effectiveness model. If we look at the level of payback of the insulation in terms of what it saves you on your electric bill, that's not really the metric we should be using. We should be looking at what is the cost of solar and PV and the true cost of carbon when we do this analysis. So for example, my project, I'm going to do R37 walls, I'll do R48 to R54 roof systems. And if you were to just pencil that out at 13 cents a kilowatt hour, it would take a long time to pay for itself. But when you look at what the avoided cost of PV panels are, and let's be frank, solar panels don't have the best recycling options as we have here in the United States. So we have to be thinking about everything that we can do really to reduce those loads to begin with. And that means using technologies that are battery friendly. Like for example, my project, I'm using all Mitsubishi inverter-based equipment. And so the amp draws of my units are anywhere between 15 and 25 amps instead of 30 or 40 amps. And that's much more battery friendly as well, because the battery technologies that are available today, they really can't take the startup loads of a big 5-ton compressor. So using inverter technologies and using technologies that are available to us, we can really go a long way to reducing our loads to begin with. And that really falls in place with a lot of what Peter had to say. My situation, I designed all 30-inch overhangs at a minimum. And then some areas that face the west and the south, I have 8-foot covered areas out in front, and so I never see any direct sunlight on that glass. And so there are things that you can do when you remodel, things you can do when you build fresh too. So lots of really options for us. So I think one of the things I would encourage people to really think about is to say, how can I make this building as energy efficient as possible? That starts with number one, keeping your ducts in conditioned space, whether you decide to do ductless systems. My situation, I'm going to have 7 different zones in my house so that I can control, I'm going to use ceiling cassettes. That way I can control the temperature in each room individually. And I'm not have to fire up a 5-ton unit to cool half the house that I'm not even in. Also thinking about indoor air quality and air tightness. Obviously, build a house as tight as you can possibly build it. And to Peter's point about houses needing to breathe, no, houses don't need to breathe. They need to be able to dry. Moisture, air contains moisture. Anytime that moisture goes from one location to another, it can condense or wet building materials. So we don't want a house that can breathe, but that just makes the problem worse. We want a house that has the capacity to dry. And you do that by having a good building envelope that sheds water away. So in my situation, I'm going to be using a very light colored stucco material, synthetic stucco on my walls, and I'll be using a rain screen lath material behind the stucco. So any water that does get behind the stucco can drain to get out of the rain screen. So there's lots of great options, and much of these technologies are available to see right here on your website, Sarah. I mean, you can go cruise the website. And then I'd also like to say that we've written 2 books for the California Energy Commission, one on retrofitting homes and the other on building zero net energy homes. It was a team of us in California that wrote the book for the CEC, and you can download those books for free. Buy them on Amazon, they're $30, but if you just go to my website, you can download the books for free, just steveeasley.com. So they're pretty short reads, but they're very to the point and practical. So with that, Sarah, do you have some more questions or?
Well, lots more questions, but so Bronwyn, there aren't that many people that can hang with Peter and Steve, but we know that you can, and they're fountains of knowledge. But Bronwyn, we asked you to join us today because you've been really instrumental in not just bringing the Passive House program here to the US, but really helping to develop passive house concepts here. So can you talk about, again, decarbonization solutions with that lens?
Sure, and thank you so much. And it is wonderful to be here with Peter and Steve, because the two of them just essentially described exactly how to build a passive house. All the concepts that they've advocated for are baked really into the passive house process, because it's fundamentally at its core a building science. It's just based on basic fundamental building science. But what I'd like to sort of dial back to is this idea of decarbonization and how, we're all very clearly focused on needing to decarbonize our built environments for all the very obvious reasons. But what often gets lost, and I heard this from Peter, and I've spoken to Steve extensively about this too, is how do we actually implement that in the field? And this is really where my journey on the Passive House sort of trajectory really came about, because I'm a pragmatic, ad heart architect wanting to deliver great product outcomes for my clients. And really, this is sort of where the rubber hits the road on the decarbonization story. And as Steve was saying, utilities are really, you're not quite sure if they're ready for what that, electrification really means in the field. And Peter, you've been talking about the programming and the upfront questions to ask clients, and then really baking in the basic concepts of air sealing, overhang shading, keeping your ducts within the building envelope. And at its core, that's what I found with Passive House, was it actually provided the targets and the tools and the training that enabled me as a practitioner at the very basic implementation level to deliver my projects to my clients that essentially guarantee excellent outcomes. And really, when the rubber hits the road, the implementation is where we have to really make decarbonization successful. And I found it was 2007, really just early days Passive House here in the US. Nobody really knew what it was. There was some sort of small trainings happening in Illinois that you had to fly there, 3 times out of the year for a week to do these trainings. And it was really hard. And learning all these fundamentals, really, we also, in the early days, we found we just didn't have the products in our market. We didn't have these triple pane windows, which, by the way, you don't need everywhere, but literally our market wasn't producing those because we'd never really felt the need for it, and we hadn't had the system that allowed us to actually see what has real impact when we choose products. So really the journey has been a really fascinating, not always easy, but always a great adventure, to where we've now been able to systemize the education process. We've got it translated into US IP units. We have built organizations across the US. We have local regional organizations based in states all around the US. And then we have a national organization, which I also helped found. So I was a founder of the Passive House California group. And then we collaborated with New York and Northwest and a bunch of other regional Passive House groups to build the national entity, which is the North American Passive House Network, or we've just sort of scaled down the name. We're now the Passive House Network. And at our core is training, because really being able to provide great tools, targets, and training to practitioners is really where we feel we'll get the most traction with supporting building decarbonization. And to Steve's point, really figuring out that the building envelope is the biggest opportunity for us to really reduce loads. Because really, when you start to say, oh my goodness, we've got to add heat pumps for everything, if your loads are huge, you've got to put 2 or 3 of those in. And that's where, you go further upstream. That's where your grid is going to start to explode. As a system, that's going to really create so many upstream problems that utilities are really going to have to handle. The next thing that we've implemented and we've started to get our practitioners to start to look at is embodied carbon. And we'll talk about that. I know you've got some questions for me on that, Sarah, but this is the next frontier of decarbonization that our codes haven't started to really be able to get their hands around. And at the practitioner level, our Passive House community is now embracing that. We've developed a tool that allows our community to look at not just the operational energy of our designs, but we can now calculate the embodied carbon impact. And it's a new tool we've shared. We've worked in partnership with our global partners to develop this tool. We've had it modified specifically for the US market. We've partnered with Building Transparency on their EC3 database for which has all the localized LCAs for all the materials that we use in our buildings. And it's a new tool we launched early this year, but it's already starting to show some quite astounding results. And back to your point too, Steve, about solar panels. The cost of those is one item, and that cost has been coming down quite remarkably. But what we're now starting to see is the embodied carbon footprint of solar panels is way higher than I had ever imagined. And in residential, it actually can be higher than concrete. So, making this discussion about decarbonization become much more integrated, where we are now able to look at operational energy impacts alongside embodied carbon impacts of materials, but looking at them together, because once we start adding PV, which we are now in California required to by code, and battery storage, our embodied carbon footprint for those two elements is ginormous. And this is where we come back to the basic fundamentals of better building envelopes. If we can build much better building envelopes, we don't need as much PV, and we really don't need much battery storage. And perhaps, the resiliency issues that Peter talked about in Texas, I think Snowmageddon was a real wake-up call, not just for Texans, but I think the whole US sat up and looked at that and went, whoa. We've all realize that we are no longer going to be able to build flimsy buildings that we can't live in during extended power outages. And here in California, we have had to deal with exactly the same thing because of our firestorms, with our utilities shutting off power for extended periods of time, leaving homeowners completely, without power and having to really find ways to live in their homes without any energy. And I think this is really going to transform our built environment rapidly. And we at the Passive House and the Passive House community are really here to support that industry transformation that is at the heart of our mission. Industry transformation, which is quite bold and ambitious, but the fundamental building science tenets baked into Passive House are really how we know we can not only survive, but we can build a built environment wherein we can actually thrive. So I think that's the hopeful message. And really the thread that runs through all of our intro presentations here is, these are really practical implementational solutions that are available to us. We just need to access them, and then we really most critically need to implement them.
Thank you so much, Bronwyn. So great intros, really appreciate that. We've got a lot to cover in the next half an hour. So I'm going to rapid fire questions at the three of you, and let's look for maybe some shorter format responses, because otherwise we could definitely all be on for about 4 hours because you all have so much knowledge. Steve, I'm going to come back to you. You mentioned your project. I'm really pleased to say that that's actually one of our Vision House projects under our demonstration project series. We call it the Revision House Scottsdale. It's a deep energy retrofit of your home. We are turning it from something that was kind of rather inefficient and unhealthy to net zero, all electric, healthy, intelligent, resilient. Can you tell us briefly about some of the obstacles you've bumped up against in the process of taking the house all electric? In particular, you mentioned some of the issues with the utility, but can you talk a little bit about that process?
Yeah. Well, yeah, the utility thing was one thing. I never dreamed I'd have to go to a 400 amp service, but that was a bit of a shock. But the nice thing is there's technologies out there, like Schneider Electric, for example. They have some of their new electric panels have the ability to load shed, so they're very intelligent and they can go through there and load shed. So I think one of the things, this is going to be a good tool for utilities to be able to use, that when people, instead of just upgrading their service to a bigger service, they can upgrade to these panels that have the ability to intelligently load shed. So that's an important part. But that was a big challenge. Was obviously I was pretty nervous I was going to have to, buy a new transformer for the utility. But the other thing too is the trades. I think it's really difficult, and for electrification to really happen and heat pumps to happen, we have to set their expectations of what these technologies can do. And so having a really good building envelope and good design is really key to all that. So you need less of it. But I can tell you that, I think the industry in general has such a labor crisis to even find people, let alone skilled labor. And the market is so incredibly busy that if you ask somebody to do something different, I mean, I'll give you a great example. Like when I told my stucco contractor that I wanted to use a product called LathNet, it's basically a rain screen lath that is not chicken wire. He just looked at me straight away and said, "We don't do that. We don't do that. So like, you want to hire me? We do it our way." And they said, well, we just don't have the capability to train our crews and to do this. So some of those labor issues are really, really significant. So we really have to address that. And getting back to heat pumps, for example, people have to understand that they are different. And, gas furnaces, fossil fuel furnaces can throw a tremendous amount of heat into the atmosphere in a very short period of time. And I think that, people are used to that. So I think one of the things that is a roadblock is certainly getting people to understand that, they're different, and we need to educate people about and setting the right expectations. But for me in my project, I think the biggest challenge has been labor, and of course materials too. But the labor issues have been challenging to get people to try new things, like advanced framing, some of these techniques that they just have no desire to embrace in this market.
Great, thank you so much, Steve. Can you all still hear me?
Yeah, we can hear you fine. And Steve brought up some points that we're seeing here in Texas. My God, to try to get people to do something other than the ordinary has always been tough, but it's even tougher. But I do want to throw one thing in, Sarah, if I may, briefly to dovetail on what both Bronwyn and Steve said is, yes, I do believe insulation is important, but it's not as important in these hot climates as people would like you to think. But I think the newer types of insulation are worth mentioning. I think the spray foam industry has done some very good stuff and possibly some damaging stuff to our industry, but that doesn't mean you throw the baby out with the bathwater. Some products like the one by Natural Polymers, what's it called, the Ultra Pure, puts out almost has no global warming potential, no off-gassing to speak of, but sticks tenaciously to the frame of the house or the building to quadruple its wind resistance in a storm. So I'm only bringing that up to make sure we're not throwing babies out with the bathwater and saying all spray foam is bad. No, there are some good products, and they do things other than just insulate. They keep infiltration to a minimum. They keep moisture to a minimum in terms of humidity coming in or out. And they can help with resilience because they can make the structure so much stronger. The closed cell version.
Thank you. I'm going to actually shift gears now. I'm going to ask you, Peter, another question, which is, why is it important for us to shift our focus from net zero energy to net zero carbon and embodied carbon and looking at the life cycle of carbon.
Well, I think Steve hit it. So often folks seem to think of net zero carbon from the or net zero period from the perspective of things like fancier heat pumps, more efficient like hot water heaters that are really heat pumps, and of course solar panels or solar systems. And I think that there's some trade-offs there that are negative, like what Steve brought up about the embodied energy content of solar panels. So I'm just going to go back to beating my old drum again here, Sarah, and say it's about the design decisions. It's not so much about the things, but we all know why we got to do this. It's getting hotter out. We got to respond to that. We've got an existential crisis that we've got to stop putting our head in the sand over. And you know, I'm just going to say this. I'm afraid that everybody's heard it so much that they do put their head in the sand about it. Everybody thinks somebody else is doing something about it, but I don't see that. At least not when I look at what my colleagues in the architecture field are designing. They are not designing climate responsive buildings, and we've got to get on that bandwagon and run hard with it. So
yeah,
Thanks, Peter.
yeah, I
I agree with you,
Bronwyn,
Peter.
yeah. No, I'm gonna keep going with my questions.
all right.
Bronwyn, you know, you have some insights into tools and data that measure embodied carbon and life cycle analysis. You referenced those a little earlier. Can you tell us briefly about those tools and some of the learnings that you've harvested to date?
Sure. So primarily with Passive House, we've been really using a very detailed energy model that really has given practitioners like myself, architects, the ability to really make informed choices. And I think to Peter's point, I've seen architects really bury their heads in the sand about the building design choices that they make because they have really very little handle on the actual real impacts that has on the building performance. And we have not, as a profession, educated ourselves and taken ownership of those decision impacts. And for me, learning how to use my own and how to drive my own energy model was transformative. Because not only did it give me the agency to make really informed decisions, but it really also gave me the tool to be able to make cost-effective choices. When you can put in a specific product into your model and then put an alternate version in and see what the energy impact outcomes are, and then look at what the cost per square foot is of that material, it's power, right? And architects have, you know, for the last 100 years, outsourced that power to other consultants. And what that does is it's kind of the equivalent of being driven by an Uber somewhere compared to actually driving the Uber or the car yourself. And, you know, you get to make the choices about which directions you go rather than just passively sitting in the back, which, you know, ironically, you know, I advocate for Passive House, and really it's a very active engagement in your design process. And, you know, the next tool that you mentioned was this embodied carbon calculator. And, you know, for many years, people in the Passive House community have wanted to figure out what is the embodied carbon footprint of these material choices that we're making. And, you know, lo and behold, our network extends globally. An outfit out of the UK, you did a software plugin for the energy model that we use in the Passive House community, which is the Passive House planning package, and sourced in all these LCAs, and then added this into the spreadsheet that is our embodied carbon, our operational energy tool. And lo and behold, we can now see both the embodied carbon footprint for the materials and the design impacts, the long-term operational energy use of your design. And the first few versions, the runs that I've done on this, we just really released it in February for the US market. As I mentioned earlier, have been blown away by how it's enabled us to visually see what the impacts are of our material choices, what matters, but how adding PV needs to be really considered very carefully. And I want to be very clear, I'm not anti-PV. I think it's a renewable energy generation source, and that's where we have to go. But it has material impacts. And excuse me, I'm losing my voice here. I was kind of shocked to see that those early results and to really see, because you only see those when you put the operational energy and the embodied carbon energy in the same model and visualize them together. And we just added battery storage into the calculator. I haven't run a building through that with the battery storage, but we know it's going to be high again. So again, if we come back to these passive strategies that reduce the need for all of those, and back to Peter's point, build less. Again, you know, sufficiency, resiliency, and just less of what we think we need is really the way to go, because it just reduces all those loads, not only on the operational side, but the embodied impact of footprint side. So
Thanks.
pH ribbon is the tool. We're starting to do trainings on it, and we are collaborating with a number of organizations to see how we can share our data on that and really help the community, practitioners like myself, to use these tools, because that is where the implementation has to happen. And I think,
thank you, Bronwyn. Wonderful. So, Steve, I want to come back to you. Clearly, all three of you, Peter, Bronwyn, and you, Steve, have set the baseline that the number one thing that you need to do and think about is first kind of analyze sustainable design, orientation, the size of a space, look at the building envelope with respect to energy efficiency and performance. So let's just say that box is sufficiently checked, right? You have a building that has, you know, a high performance building envelope. It's designed sustainably. It's the right size, et cetera. Beyond that, right? What's the next step in terms of the most important advanced technologies in the transition to a decarbonized built environment?
Yeah, I think, well, one, I want to echo what Rowan said, that with regards to PV, I don't think any of us are against PV. It's a really critical part of decarbonization. It's a really critical part of electrification. It's certainly a very important part of my project. So I don't think any of us are anti-solar at all. So we don't want to get people to misinterpret that. We think it's a really critical part to this. But, you know, when we talk about modeling is great. Because it does help us make intelligent decisions, but relying upon modeling for performance is a huge, huge mistake. We don't know unless you measure. And so it's important to use modeling as a tool to help us make decisions, but it's also important to use diagnostics as a way to make sure the building is actually performing before it's done. You don't wait till the building's done and just do a bunch of measurements and find out it didn't work. So you have to have monitoring every step of the way through the process, and that means lots of inspections. So for example, I always recommend you do one inspection just before the cladding goes on to make sure the building is completely dried in, that there's no opportunity for water leaks and things that lead to premature failure. Almost everywhere in the codes now, we're looking towards exterior insulation as even a requirement in the next round of the codes, climate zones 4 and above. But in many, we're seeing exterior insulation used almost everywhere exclusively now. And if you get water between an impermeable foam sheet material and the OSB, you're asking for trouble, right? So inspection at that space. Next inspection would be before insulation to make sure the building is airtight. And that's pretty easy to do visually even. But, and then also if you could also do blower door testing at that time as well, if you have drywall in the ceiling and seal off the garage. So that inspection, and then inspection just after installation. But you need to have a process of inspections and analysis to make sure that the units are being charged right. 6 out of 10 residential heat pump or air conditioning systems are not adequately charged. They're as much as 25% are undercharged or overcharged. And if you're undercharged by 25% or you're overcharged by 25%, you know what that does to your capacity? It takes a 4-ton unit and turns it into a 3-ton. So all these things are really critical. It's not just about design, it's also about modeling and documentation and evaluation. So I can't emphasize that enough. It's really important. And we have all these great tools like infrared thermography. We have duct blasting capabilities. We have devices that we can use to seal houses like Fix-A-Flat. So there's all types of technologies that we have at our disposal, but it really takes measurement along the way, not at the end.
Totally agree, Steve. And I think you've seen the projects that I've built with Alan at One Sky Homes. We've been doing exterior insulation for a decade and more. We've been doing heat pumps, all electric, since 2013. And so we've really pioneered a lot of these things and experienced a lot of those, bumps in terms of the labor, getting subcontractors to do different. And I have to wholeheartedly agree with your on-site verification is key. It's very much baked into what you have to do as part of your passive house process. And what we did post-occupancy monitoring and verification has been an absolute eye-opener in terms of the passive house journey that I have been on. Alan and I committed to every house we built. We monitored it for 2 years post-completion. And that data capture, along with allowing our homeowners, our clients, to see exactly what energy they're using and consuming, has been phenomenally helpful in confirming that our models have actually been ridiculously accurate, like to within 2% accuracy, heating and cooling, and really gave us confidence that what we were doing and implementing in the field actually was working. And if people are not into certification, I highly recommend that they do post-occupancy monitoring and evaluation as their insurance policy. And I'm seeing a lot of builders sort of really dabble in that idea of offering post-occupancy monitoring as the guarantee, the warranty of service. Contractors, actually, this is a tool that will really help you. In California, contractors are on the hook for 10 years after a house is built, if it's new, and 5 years for housing that has been retrofitted. If you have the data to see exactly what energy is being used in the house, you really get to see what actually may or may not be working. And in our journey of actually doing that post-occupancy verification, we found compressor units who were cycled that actually were built according to spec. So we were able, through our monitoring, to actually go in, find the problem. We could see it from the data monitoring. It was this compressor unit was using an enormous amount more energy than it should have, according to what the manufacturer spec was. We went in, we saw that the element was just cycling onto heating and chewing up an enormous amount of energy. We could fix that. It was the manufacturer problem. We've had issues with heat pump water heaters. We've seen the energy used from the monitoring data. We've been able to go in, fix it before it was a real problem. And we actually also found some really fascinating items like the induction cooktops that we put in. From our early monitoring data, we were seeing those using what looked like to be much more energy than they should have been using. And we called the manufacturers and we said, hey, your induction cooktop's chewing up all this energy. And actually what we ended up, they said to us, hey, you're using this monitoring data that's actually messing with the magnetic mechanism in the induction cooktop actually was sending a ghost signal to the monitoring connector, and we literally had to turn off all the systems in the house except for the induction cooktop, and see that the meter didn't keep running to verify that what the manufacturer told us was correct. So
Was it?
Interesting. Yeah, great. So
no, it wasn't using more
we have
energy.
about 12 more minutes, and I know Mike has a bunch of questions from the audience. So Mike, I'm going to kick it over to you and have you jump in and ask try to rapid fire some specific questions, please.
Yeah, we do have an inquisitive audience today, and I wanted to start off with kind of an easy one. This is for Bronwyn. You mentioned a tool earlier. Can you repeat the name of that tool, please?
Sure. The tool is pH Ribbon. It's available on our website. If you go to naphnetwork.org, and you'll see it right in the top toolbar. We're really doing trainings on it, but it's a very affordable plugin for the Passive House Energy Model package, and I'll put a link to it in the chat if you want to share that. I'd be happy to have people learn about it. We're doing a training on the 26th of this month, so coming up next week.
Awesome, thank you. Peter, there was a question from Tom, because you were talking about infiltration and certain benefits of spray foam products. But when a building's conditioned and the moisture content of the wood framing drops from, let's say, 19% down to 10%, cuts in half, some of those studs will shrink by 1/16 of an inch or more. And sometimes that will pull away from rigid foam products and allow infiltration and reduce added strength. This is what Tom's telling me. So his question is, because it's hard to quantify those effects, because who goes in and studies these houses 5 and 10 years later, what are your thoughts on using SIPs instead to try to mitigate?
Mike, we've built a few SIPs homes in the earlier years, 20, 30 years ago. We probably haven't built one in probably 15 or 18 years. I think SIPs panels were fantastic. But of course, we saw other things going there too. By the time they were cutting in some of the electrical boxes or cutting into the vaulted ceiling for light fixtures, we were doing some pretty significant damage to the envelope in terms of keeping infiltration losses down. I think every system's going to have its problems and it's going to have its benefits. For at least what we do, which is custom homes and custom buildings that are not cookie cutter, there's no substitute for a good foam product. There's also no substitute for good construction practices, making sure that you're not using wet lumber, or if you are using wet lumber, give it a chance to dry out, which usually in our climate being so dry, it gets to do, it's drying out long before it's insulated. So I'm not ready to throw the baby out with the bathwater there either and just go with a different type of insulation, because all the others have even more potential gaps, with the exception of structural insulated panels. But again, I've also seen structural insulated panels hacked to the extent that you still have problems. Yes, they would be best, probably so, as well as something like insulated concrete forms. But in terms of the roof structure, spray foam is fantastic with gluing itself to the rafters and to the underside of the roof sheathing. So are structural insulated panels. So what am I saying? Well, I suppose they're both great systems. Maybe SIPs are better, but you got to make sure it works with the other aspects of your design.
Okay.
I've inspected thousands of homes and not have seen very few instances where the spray foam is separated. They don't tend to, typically when that happens is when the spray foam is not sprayed on ratio. And so if it's chemistry is sprayed in too low a temperature conditions, you see that happen. But I've looked at thousands of homes and not really seen an issue from lumber shrinkage causing the foam to pull away.
Steve,
and I'll just throw in a couple of details there. Sorry, Mike. There's really great details that you can use with SIPs to mitigate that damaging of the thermal envelope. You can put a mechanical chase interior wall for retrofits or new builds that holds the electrical and the plumbing and any HVAC stuff interior of the actual insulation of the SIPS panel. There are lots of really good design solutions that can allow those products to not be, have the integrity compromised. So design details, really architects have so much agency and so much opportunity to do things better and to use products to their strengths and then compensate for the weaknesses, potential weakness of those products in really creative design detail solutions. So I think I'm with you on that, Peter. We see the benefit of using spray foam products in very specific details and using them to their strengths where they serve as the best available product for certain specific uses.
Well, it's interesting. Tiffany brings the point of, will foam really ever be a part of a circular economy? So that's something to think about as we've talked with some of our speakers from earlier.
I think the answer to that question is the better foams, the newer foams. Yeah, I think you got to be discriminating with the foam you buy. Yes, that ultra pure product I mentioned earlier, and I'm not doing a commercial for them, but I love it when I see companies that really do try to do the right thing. Yeah, it's more expensive, but they make sure their technicians are trained. They know how the spray and the off-gassing is minimized and the global warming potential is minimized. That's important.
A lot of the products. Here's the other thing to remember too. Don't forget that if you ever bought engineered lumber, OSB, I-joist, these paralams, they're all made with MDI. It's the same chemical that goes into spray foam. So spray foam really gets a bad rap. The reason we have these formaldehyde-free products is because of MDI, which is the principal ingredient in spray foam. So I think it gets a bad rap. I think you just use it smart. And I'm using froth packs to provide 2 inches of closed cell spray foam in my project because I think it's a great solution for air sealing, and I'll finish off the balance with blown fiberglass for economics.
Yep, we do the same, or cellulose, or even mineral wool.
Yeah, no, I think product availability is key though, Mike. And I think, what we've seen here in the West Coast, in our passive house community, in the early days, we literally didn't have product selections we just didn't have options. So we had to use what we had readily available. We were using polyiso sheets for exterior insulation. We used some spray foams, but now we have options, and we are seeing more and more of these options come to the market. We then got mineral wool, which took a while to get to the West Coast. My colleagues on the East Coast have been using it for a lot longer than we had. Now we are seeing the wood fiber products that are coming that are actually quite amazingly low embodied carbon. They've been imported from the European market for a while, but there's an outfit in Maine actually scaling up production of that. We're seeing all sorts of fabulous innovative products come to the market that will give us choices, including sub-slab insulation. There's aero aggregates, there's Glavel. These are aerated glass it's a waste product from additional industries. We're being able to insulate below our slabs with a waste product, aerated glass. So all these lovely innovations that are happening in our product market are really transforming the choices that we can make. But the awareness of what the impact is and what the embodied carbon of those products are is key, because we need to be able to make our choices in a really informed, transparent way. And this is where these tools that allow us to see what the embodied carbon impact is of the materials choice we're making is really where I think our entire industry has to go, and the codes and the regulatory environment also has to start to integrate that.
Mike, question. Do you have another question? If not, I wanted to add something quickly onto that.
I've got about 6 questions, but I'm not going to be able to get to them all. So we were talking about insulation. Steve, there was a question sent in specifically for you. Bernadette wanted to know your opinion on blown-in wool insulation, especially in humid climates.
Oh, I'm not going to use it in my project, and I can use anything I want. I'm kind of agnostic about different choices of insulation. I think they all work, really. They can. It's really about how you apply them. So, wool is a remarkably, it's a remarkable product. I mean, they can be totally wet and still retain 90% of its insulation value. So if the question is regarding using wool in a climate that's hot and humid, or even humid, I wouldn't be afraid of it. Simply because, it's worked well on sheep for, billions of years, right? Or millions of years, probably billions. And it retains 90% of its R value even when wet.
So we're getting close to the end of our time. I want to conclude on this question, and this is for the whole panel here. It comes from Lauren, and she wants to know, what is your advice to a municipality interested in starting an incentive program for existing building retrofits with the goal of reducing greenhouse gas emissions? She's curious, where would you start in developing that type of program?
I have a great idea, and I'm really excited to share with you. You can go straight to your county assessor's office, and we should be offering a tax credit for people who build zero energy homes or remodel their homes to be zero energy that are certified. So let's say, for example, your property taxes are $12,000 a year. If your property taxes are going to be based on the value of the home. If you're building a Z&E home or you're remodeling your home to be Z&E, you would get a certain tax credit off your property taxes. That would be a great incentive to get people to, embrace, electrifying and zero energy homes. And that wouldn't cost. And then, of course, when that house sells at the end, when that person sells that house, then it goes back to its basic tax rolls. And we all know that solar collectors add about 4% to the value of a home, according to a study by Zillow. So the tax revenue to the overall net tax revenue to the city is really not going to be compromised, because they never had that tax on the rolls to begin with.
Yeah, I think I'd add to that, Steve. Sorry, Peter,
No, go ahead. Go ahead.
Two things. Cities should require energy use disclosure at point of sale. That will really move the market to actually visualize the energy use of a house at sale. So that's the first thing I would say. Cities can easily implement that. I know there are cities in California that have started to do that. And then the second thing I talk about during COVID as a COVID economic stimulus plan, Italy implemented 110% tax rebate program for people who exterior insulate their homes. And they were primarily for existing buildings, but it could also be for homeowners and renters and second home building owners. And this has completely transformed their economy, because tradespeople have been put to work doing retrofits. And there are exterior insulation retrofits with some rebate money available also for heat pump installation, getting rid of fossil fuel appliances. And it's really transforming their economy and massively reducing carbon emissions from operational energy and stimulating the economy. The money from, it's all localized labor is being paid to do this work, and the money is getting completely 110% rebated to the property owners or the renters. So it's a phenomenal program that we should be implementing here instead of giving gas.
Could I push something that's practical? I hear that, Bronwyn, but I think, first of all, there's cities in America that have done this ahead of you. 30 years ago, Austin implemented the first green building program in the country, and they had their weatherization program. First and foremost is find out something, develop a program that deals with infiltration losses. No matter whether you're in the northern climes or the southern climes, weatherization is going to be number one, hands down. So if you have any questions about that, I would look up the Austin Energy Green Building Program and how they did that. But infiltration losses are number one. In some areas, Bronwyn, exterior insulation makes a great difference. In some areas, it doesn't make as great a difference. But in every area, infiltration losses make a difference.
I think we're going to wrap it up. I'll, first of all, Steve and Bronwyn and Peter, thank you so much. Clearly, we could stay here for another 6 days and talk about all kinds of interesting things. You know, your knowledge is quite limitless, and you know, I'm sorry that we only had an hour to just scratch the surface. But I think what this panel really did was to bring some of these higher level concepts that we've spoken about yesterday and earlier today into, you know, a very tangible light with respect to things that we can do in the housing sector, in the construction industry in general, for builders, developers, municipalities. And, you know, it's clear we've got one job, right? And that is keeping global temperatures from rising above 1.5 degrees Celsius, a point at which we know will have disastrous consequences. The good news is, as you all have shown us, we have the tools, we have the resources, we have the know-how. It starts with sustainable design. It moves into, you know, a tight building envelope on 6 sides of a home or a building. It then moves into technologies like heat pumps and induction cooktops and solar plus storage and, you know, other advanced technologies. And then it also leads into how we live in our homes and the decisions that we make, you know, moving us towards circularity and regeneration. And again, the good news is we have market available solutions and strategies and products and technologies. We have the know-how right now. It's just about the courage to take that leap. So Peter and Bronwyn and Steve, thanks to all 3 of you for your leadership in this area. You know, we have the good fortune of being able to work with you all, not just for this symposium, but in other ways and in other projects, and looking forward to long-term relationships with you. Thank you also to everyone in attendance. Just the fact that you're here shows that you are also critical thinkers, and you are essential in the transformation to a decarbonized economy. So we really appreciate you all spending time with us, listening to what all of our experts had to say. For more information, please do visit us at greenbuildermedia.com. My contact information is on there. Please feel free to email me. I know that Peter and Bronwyn and Steve would all love to hear from you. Of course, Mike is always open to responding and commenting on emails. We invite you also, if you want to learn more, to register for our Housing 2.0 workshop series with another building industry luminary, Sam Rashkin, to look at how we can design and construct the next generation of homes. And as always, you know, again, thank you so much for your commitment to sustainability, as well as your support of Green Builder Media. And thank you again to Train Technologies and Scott too for your support of our annual Sustainability Symposium. So with that, Mike, I'll send it back to you for any final comments, and thanks for being a great moderator.
Thank you, Sarah, and I just want to say thank you all for attending and asking questions. Sorry if we didn't get to your question, but truly thank you for being here. Otherwise, we'd just be talking to each other. So I hope you have a wonderful Earth Day tomorrow. See you right back here next year for next year's Sustainability Symposium. Take care, everyone, and so long.
Thank you.